Hey everyone, welcome back to the channel. In today's video, we're diving into an exciting and fundamental concept in programming, the Fibonacci series. Whether you're a beginner or brushing up on your skills, this topic is a must-know for understanding recursion, dynamic programming, and more. So, let's get started. The question is simple yet powerful. You're given a number n and your task is to find the nth number in the Fibonacci sequence. But what exactly is the Fibonacci sequence? It's a series of numbers where each number is the sum of the previous two, starting with 0 and 1. So, the sequence looks like this. The challenge is to calculate the nth Fibonacci number efficiently. Let's explore how to solve this step by step. In the Fibonacci sequence, n represents the index of the number in the series. The sequence starts at index 0, where f0 is equal to 0 and f1 is equal to 1. For example, at index 8, the Fibonacci number is f8 is equal to 21. This pattern continues as each number is the sum of the two preceding ones. Understanding this indexing is key to solving the problem effectively. The equation for the Fibonacci sequence is simple and elegant: fn equals fn-1 plus fn-2. This means that any Fibonacci number at index n is the sum of the two previous numbers in the sequence. With the base cases defined as f0 is equal to 0 and f1 is equal to 1, this equation forms the foundation for solving the problem. To solve this problem, we'll first use recursion, a straightforward and intuitive approach. In recursion, we break the problem into smaller subproblems, where each Fibonacci number is calculated using the previous two numbers. Let's dive into how recursion works for this problem and explore its strengths and limitations. Let's break down how recursion works with an example where n equals 4. We'll construct a recursion tree step by step and see how the calculation happens. First, we start with f4. To calculate this, we need f3 and f2. Let's focus on the left side first. For f3, we again split it into f2 and f1. Now, for f2, we further calculate f1 and f0. At this point, we've hit the base cases where f1 is 1 and f0 is 0. Now let's move back up the tree. f2 is calculated as f1 plus f0, which is 1 plus 0, giving us 1. Then, for f3, it's f2 plus f1, which is 1 plus 1, resulting in 2. Finally, at the top of the tree, we calculate f4 as f3 plus f2, which is 2 plus 1, giving us the answer 3. So, the Fibonacci of 4 is 3. That's how recursion works step by step to solve this problem. Now, let's start coding in Python. Don't worry if you're familiar with other programming languages, the logic we're going to use for Fibonacci will look almost the same in any language. The syntax might differ a little, but the core idea of the solution remains the same. Let's break down the code. We are given a method called fibn which calculates the Fibonacci number for the given index n. The first line of the code is def fibn, where def is used to define the function, and n is the parameter representing the index of the Fibonacci sequence. Inside the function, we handle the base cases with the condition if n greater than or equal to 1, return n. This means that if n is less than or equal to 1, the function directly returns the value of n because we know that f0 equals 0 and f1 equals 1. For any value of n greater than 1, the function proceeds to the recursive step, or it calls itself twice, once for fibn-1 and once for fibn-2, and then adds the results together. This is the core logic of the Fibonacci sequence, where each number is the sum of the previous two. Finally, the function returns the Fibonacci number for the given n. And that's how you can solve the Fibonacci problem using recursion. However, let's talk a bit about its time complexity. This recursive solution has a time complexity of big O, 2 to the power of n, which grows exponentially as n increases. That's because the function ends up recalculating the same Fibonacci values multiple times, making it inefficient for larger values of n. In the next video, we'll dive deeper into the limitations of this approach and explore a more optimized solution to calculate Fibonacci numbers. So, if you found this helpful and want to learn more, make sure to like, share, and subscribe to the channel. See you in the next video.